This is our pre-lab for projecting trajectories. Our goal is to determine where the ball will land on the floor in relationship to the table. The ball will roll off a metal ramp on a very small incline, roll onto the table, and then roll from the table to the floor. We are determining where it will land on the floor, and that's called our horizontal displacement. So for part one, we have to determine the horizontal velocity vector. This side we have to understand in the following ways: that our acceleration is 0. There's no acceleration since no force acts on it horizontally. The only force that acts on it is gravity, which is the vertical motion. We determine Vx, our horizontal velocity, by taking horizontal displacement divided by time. Dx is what we're determining. Time will be determined through the vertical motion, and that's through a vivitat, accelerated motion. Gravity is accelerating the ball downward. The supplies you need are a sheet of paper, which will be like our target, carbon. We will have a timer and a meter stick. Over here is our setup. So we have a ramp on a small incline, and then that distance that the ball will travel on the lab station should be about a half a meter, not 3/4 to a meter. That if it's too long, the ball has too much variance in how it's rolling. It won't roll as straight. And then here's our timer. So each time you roll the ball, it should be rolled from the same height. Okay, so when we do it again, what we want to do is time it so that once it leaves the ramp until the end of the table, that's the only time that it takes. We need to do this 5 times, and we can go. We would say we're rolling it from the same height. Go ahead and let it go. Start time, stop time. So we do that 5 times. So for part one, that's the distance, and that should be, like I said on here, 0.75. Let's shorten that to 0.5. Small angle. How long does it take the ball to roll this distance? And that will be our horizontal velocity. Do this 5 times and take the average. So the speed or the velocity of that ball is the distance, in our case is 0.51 meters, divided by the average time. And that is all we need to do for part one.